All right, folks, welcome to another episode of the Flying New Guy, this guy right here. And today we are going to continue our discussion on electricals, on systems, starting with the electrical system. So if you haven't seen yet, the format of this is kind of like an informal ground school, except it's comfortable. There is no whiteboard. And then there's Tom right here. He's back. He was kind of stuck in the snow last episode. And Penny's back too. She's right here looking at us. And there you go. She's moving away now. And okay, so Jason, let's get started with the electrical system. This is always, by the way, students hate the electrical system. Every time I've taught this, and I don't know your experience, but my experience has always been students just don't understand electricity in general, don't like the electrical system. There's a lot of questions in there that they just don't get. I know you're a bit more advanced because you've been playing with drones and you know how all that stuff works. So we'll be grilling you today. First, to get started, electrical system, DC or AC?
I hope it's DC.
Yes, DC.
I hope it's DC.
So DC stands for?
Direct current.
Direct current, okay. And voltage, what's the voltage for a battery in 172?
Voltage for a battery?
Yeah.
I think it's 24 volt. I think.
It's not. What is it?
28
28 volt. Is there a reason that it's 28 volt and not 24 or 12 or a multiple of those like most other stuff we see?
There is a reason. The alternator, I think, is creating the 28 volt system to recharge.
Yeah, it gives you that little buffer in there. And there are some aircraft that are 12 volts, and it's kind of goes back and forth. You know, sometimes they, just like with models, they change it, and then it turns into, they go from 28 volt latest and greatest to 12 volt the latest and greatest, and then kind of back and forth.
So what's the main source of electricity in the aircraft once the engine is turned on?
Alternators.
The alternator, okay. And when it's not turned on?
The battery.
The battery, okay. So we use the battery to do two things.
Turn the engine on.
Turn the engine on. And then what?
In the event your engine quits?
In the event your alternator
fails or your engine
quits, then yes, you have.
If you lose power, your battery is your backup for however long the battery lasts.
Yep.
Well, here's a question to expand on that. You're up in the air, your engine fails, but your prop is still spinning. Is your alternator still generating current?
Well, yes, because it's an electric motor. So as it spins, it's going to generate current in reverse of whatever.
Yeah,
in reverse. It's still working.
Still spinning.
It's still
working the same way. Yeah,
it's
still working normally because that prop is spinning, which spins the engine.
Yes.
So
which creates electricity.
Which
so yeah,
current.
Absolutely, it would. You would know.
ram air turbines work.
Yeah. Then we have something in there that allows us to figure out if our alternator is working or not working. What instrument is that?
I don't remember what the instrument is called.
What does it tell us?
It tells us the charge rate of the battery.
Okay. So that would be the M meter.
Amp meter?
AM meter.
AM.
Yeah, M meter.
Okay.
Which is amp meter if you want to think about it that way. So the amp meter, there's two different types. There is one that will just show a positive number. Some of them will show a positive and a negative number. What experience do you have with?
I've seen the ones where it's usually I've seen the ones where they're just positive, or it'll show positive and negative. It'll show a draw.
Yeah.
Where on run up on some of the older Cessnas that I've flown, you would turn the alternator off and you look for a negative. I think with the Archers that I flew, it was the same thing. I don't think I've seen one that just shows the load. It's like, what's that? A load meter?
Yeah, load meter on it basically shows if you if you have a current draw. So if something fails, then it's showing that you're utilizing the battery and not using the alternator. So what does the electrical system power in the aircraft? You have ideas of different systems?
Ideas of different systems? Do you mean like...
What does the electrical system power? Why do we need an electrical system?
Lights, and if you have a glass cockpit, it's probably going to power your glass cockpit.
Yep.
If you're using the steam gauges, though, I don't think it powers any of your 6-pack. Does it?
What runs the directional gyro? No, I'm not. I'm sorry, not the directional gyro.
Turn
the
coordinator.
The turn coordinator.
It's a
Is the turn coordinator?
it's a gyroscope, but
It's a gyroscope
an electric gyroscope.
actuated by electricity. Yes.
That's the only one out of the 6-pack that is electrically driven, correct?
How are the other
other
ones
three
driven?
are pidostatic. Well,
No, the attitude
there's-
indicator and the directional gyro are.
there's 3 that are
Okay, we're talking about gyroscopic instruments. Okay, which 3 are gyroscopic?
the
Turn coordinator. We already
Turn
talked about
coordinator.
that one.
yep,
Okay, what's the other 2?
your heading
Okay, that
Heading-
I'll give you that
heading
one. The
indicator.
directional gyro.
heading
Yeah.
indicator, and then your attitude indicator.
Yes.
So those 2, the last 2 you mentioned, how is the gyro inside
vacuum
actuated
system.
with the vacuum system?
Yes.
So those are vacuum based. And then the reason why you have an electric based is a backup. So if you lose your vacuum system, then you don't lose
Okay.
all 3 instruments, you
Right.
only lose 2. Now, granted, you could fly the airplane with the rest of the instruments, the pidostatic system ones, but it's better to have it this way so it's going to spread out. And that's also on the pidostatic system. If you lose the pido tube, you're only losing 1, you're not losing the other 2.
Mhm.
That's kind of the redundancy type of thing that we see in aviation generally. You talked about the lights. What kind of lights do we have on the aircraft?
We have nav lights and beacons.
Nav
and
lights,
landing lights.
landing lights. One more.
Nav lights, beacons, landing lights,
It's white and flashes.
strobe light.
Strobe light.
Okay.
Okay.
And
So-
on some aircraft, taxi light.
And on some aircraft, taxi lights, which are located with the landing light.
Yes, there's some.
Close to it.
Yeah, and there's some that have taxi lights that are underneath the wings.
It gets confusing.
Yeah, there's a lot of lights.
And yeah. So nav lights, you mentioned nav lights. What are those?
We have lights on both the wingtips and the tail.
Okay. What color?
Red, green, and white.
Red, green, and white. Okay. What's very specific about the white one?
The white one faces backwards,
The back of the aircraft.
which it faces the back of the aircraft, but it could be confused with a landing light if your landing light is on in flight.
Yeah. Well, I think you'd be able to see it because the position of the landing light usually is, well, not always. Sometimes it's in the nose. Yeah, that's the confusing thing about these lights is every aircraft is a little bit different. Okay. Let me keep going through here.
When are the nav lights required to be
Oh.
illuminated?
That's a good one.
One of the nav lights required to be illuminated
Yep, when you got to show the red, green, and white.
at night or during VFR or IFR.
A little more specific.
A little more specific.
Sunset to sunrise.
Sunset to sunrise.
Which night?
Which night?
One of the 3 night
Right.
definitions.
Sunset to sunrise.
Yes.
Okay.
What would you do if you're looking at the circuit breaker panel and then one of them is popped up, is just out?
I would try to determine why
Yep.
before I
Push it back.
push it back in.
What if you push it back in and it pops again? What would you do? Don't push it back
It's going to say leave it.
in. You'd laugh, but I've seen students be
leave
like,
it.
"Pop." It's like whack-a-mole.
Right. Pushing it back in constantly.
Pushing it back in. There's a reason why it's popping. There's a short somewhere.
You
So
shouldn't screw the breaker open on your house.
That's right. Yeah, you don't.
Bad idea.
Yeah. So yeah, there's a short somewhere, which means that you could end up with an electrical fire, which is one of the worst thing you can get, I think, in flight. Is an electrical fire because it's right by your legs. It would be burning your legs. Can't touch the rudder pedals anymore. You can't. It's just a bad situation. Smoke coming in and all that good stuff. So, if you had, let's say we're talking about the electrical system. If your battery failed and your alternator failed, would your engine fail?
It shouldn't, because your magnetos are direct driven, right?
Yes.
So your engine should continue because your magnetos are driven directly by the crankshaft on the engine.
Correct. The only aircraft that this is not true for is what? Or type of aircraft? Do you know? You may not know that.
I don't know off the top of my head.
So the FADEC driven aircraft, the Diamond, the DA-42, have a backup battery that runs the whole electrical system that helps with controlling the engine, because the FADEC is a single throttle.
Does it have auto throttle on it?
Some of them do, but that's not even about the auto throttle. It's about the fact that the engine, there's something that controls everything that goes on into the aircraft. So
Yeah.
you have backup batteries, and if you lose that, then you basically have 30 minutes of flight before you may lose the engine, which is, I always thought was kind of interesting from a design perspective. There's one element that you haven't mentioned that is powered by the electrical system that's quite useful when you go to controlled airports.
Radio.
Oh, your radio. Okay. So when you're in flight, you lose your radio. What happens? I know you haven't flown yet, so it's a bit of a tricky
I'm
question.
I'm like, oh no,
Have you gone over lost comms procedures?
not yet.
Not yet.
No,
Yeah, I'm reaching
no.
out.
Like you cry
Yeah,
if
no, it's actually
if you
not
have a
that bad.
transponder, you
Chances are, you could have lost your radio. There's usually two of them in most aircraft these days.
okay.
So you could always switch to another one. Now, if you had a full electrical failure, then you wouldn't have your transponder. You wouldn't have much of anything left.
Wiggle your
there's-
wingtips when the fighter jets get there.
Well, there's light gun signal, right? There's light gun signal. There's
That's
lost
true.
com procedures that you can follow. You'll learn that. We'll talk about that in airport operation in the future. Okay, electrical system. Any other questions on the electrical system?
Yeah. Have you gone over in-op procedures yet?
If it's some of
Okay.
yeah.
So let's go back to you got a breaker popped out, you push it back in, pops back out. Push it back in again, pops back out. A little bit of whack-a-mole, right? So then what do you do if you still want to conduct the flight? What is your steps and your procedures?
You have to determine whether or not that piece of equipment is required to fly.
Right?
And then if it is not required to fly, then you can placard it in hop.
Okay.
As long as it's I don't remember if this is minimum equipment list or not, but as long as it is
So first thing
noted
you do,
in the
right?
maintenance log and has worked on within a set amount of time.
So you're close. That's a pretty good answer for the level that you're at. So what you want to do, first thing, does it have a minimum equipment list? Then you're going to follow minimum equipment list. If it doesn't have a minimum equipment list, we're going to check and see if it's something required in 91205. If it's not required in 91205,
Tomato flames, the two tomato flames and flames.
yeah, or camel's foot. Then you're going to determine, is it going to constitute a hazard? If it's not, you placard it in op, and then you make a notation in the logbook.
Notation in the logbook is what I was missing.
Okay. Yeah, but that's
Okay.
but for as far along as you are, that's a good answer. There's a lot of guys that are getting ready for the private check rides that can't even get as far as you did. So that's good. I'll give you that one. So that was the only one that I got for that.
That will definitely be a question asked by the
STP.
examiner when you do your check ride.
Yeah, and in-op procedures 91-213, and it flows just right through.
91, 91-205, 91-213. Those are the two keywords you want to remember. And then in there, it walks you through everything you need to check. So
There. Yeah,
you
you just
can-
go through the reg just like it's a checklist, and you're
Yep.
good. So
another system on board the aircraft is the hydraulic system. What does the hydraulic system power? There's a few things.
Power?
Well, I mean, what do we use it for? First off, what's hydraulic? How does it work?
Hydraulic uses a fluid that is not gaseous to
Mhm.
drive essentially pistons.
Non-compressible fluid.
Non-compressible fluid. Well, that's a non-gaseous fluid.
Mhm.
Should be non-compressible.
Yep.
So
In our small airplane, there is really only one thing that it's used for.
Flaps?
Nope.
No?
Well, no. Usually flaps are either electric or manual.
Okay.
Yeah, the larger aircraft have hydraulic flaps.
Yeah, not
but
the smaller,
not
not
the smaller
smaller
ones.
ones.
The constant speed prop runs off of a hydraulic system, correct?
Yep. How do
I mean-
yep, it does.
Kind of. If you had retractable landing gear?
Yeah, retractable landing gear. Some of them, most of them do, either for extending or for at least for retracting. Some of them extend using just gravity,
Right.
but some of them use pressure as well.
Okay.
You're missing an obvious one. How do you stop the aircraft on the runway?
Brakes.
The brakes. Okay. How does it work? How do the brakes work?
Are they not just disc brakes?
Yeah.
Okay.
So
Then disc brakes use a caliper that squeezes a
yep,
plate.
you
and
get pads on each side. It's going to squeeze on a disc, and then it's going to stop you. Where do we have brakes? Do we have brakes in the front, on the side, on all wheels?
all wheels?
No.
No?
Just the mains.
Just the mains. Yeah, the front doesn't have
Just the mains.
just the two. Penny sneezing. Just the two main wheels.
Okay.
Yeah, and you'll see that when you do pre-flight, you'll pre-flight the aircraft and you'll look at the pads, make sure that there's still life on the pads, and make sure that disc is not all rusted out. And
Make sure you're not
Although-
going to weld the brake to the
Yeah.
caliper.
so the tricky thing with brakes, by the way, is that you don't have ABS. So how many flat spots have you made on aircraft?
None.
None?
Officially.
Not officially.
Yet. I think I've only did one when I was a student pilot, but I've had plenty of students do them to me. And then after you do that, so you burn a piece of the rubber on,
Mhm.
and then you're taxiing around, and because it's like kukung, kukung, kukung on the runway.
Yeah, as far as I've known, I have never actually locked up the brakes. I've always been cautious not to do that.
So if you fly the 182 RG was always famous, because the 172, the brakes suck. I mean, there's no other way to say it. So people will go from the 172 to the 182
And they
RG,
lock them up
and
all
then
the time.
and then they just basically, and the brakes work well on the RG, and they basically just go in there. So when I managed the flight school, we had 182s. And anytime we had a student do a flat spot, which, by the way, tires are expensive, we would have them go to maintenance and change the tire with the maintenance guys. And then that was their punishment for
Along
making a flight
with
spot.
paying for the new tire.
Well, no, we never did that. But yeah, that's, yep. Let's talk about, we talked about landing gear, and I know you're probably not going to fly a retractable landing gear aircraft anytime soon, but landing gear malfunctions happen. I got some stories on that. But how would you deal with you put the gear down and all of a sudden it just doesn't work? It's not there.
The gear,
First off, how would you know that it's not working?
should be an indicator in the cockpit, right?
Yep.
That the
Yep.
gear is down and locked, or
Correct. Yep.
down and not locked, or that certain gear are down and
or in transition.
or in
Okay.
transition. Yeah.
transition.
So depending on the aircraft, but yeah, you'll see typically when the gear's in transition, there's a beeping.
Okay.
When it's down and locked, there is lights.
Mm-hmm.
And then if you get to a certain level of throttle, and the gear is not down, then you'll get a warning
The gear is not down and the gear is down.
that the gear is not down. So if you reduce the power to a certain level,
Oh. And I was thinking the opposite way. If you throttle to a certain
no
amount.
it's- So the
Okay.
idea is that you get close to the runway and you go power to idle to
Yep.
level off, and if you have that power too low, or you're getting in the pattern really, and you start to pull back that power, then you'll get a beep 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 beep, and it just keeps on going until you put the gear down. And that's your warning. And there's a video on YouTube of a 172 RG, which are pretty rare. So it's a 172 with retractable landing gear, and there's two guys flying together, and there's a dude in the back filming. And the whole time they're
Mhm.
on approach, and it's beep, 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 beep. You can just hear it beep. And they're tone deaf at this stage. And people say if you fly instruct a lot, when you do a lot of maneuvers in the pattern or outside, you don't usually put the gear down. So if you do slow flights or if you do other things, and you hear this all the time, you hear that beeping all the time, and you just get used to it. So you could be sitting there, this thing is beeping at you, but it's not beeping loud enough or annoyingly enough that you just decide to do something. So this guy comes in, 172 RG, comes in, no gear down, and all of a sudden they're right over the runway, cut the power, and you can see him. He goes like this. And yeah, sure enough, just scrape the whole thing. So yeah, that's a safety thing. So back to your malfunction. Let's say one of your gear is down, the other one is not down, and then the nose gear is down. What would you do?
Put all the gear back up.
Pull up the gear back up. What would you do?
I'm gonna pull the emergency switch.
Emergency
do?
switch.
What does that do?
So what that's going to do is that's going to equalize pressure, and your mains are held up with springs, they're held up with springs. When you pull that, when you pull the emergency switch, it's going to allow the gear to descend. It's going to equalize the pressure, so there's nothing holding it, and gravity will drop them down. In theory,
In theory, if it's not stuck. So I've had situation where we had an aircraft that had the nose gear stuck inside. In this case, I would land with a 2 main, because you can still control the aircraft and then let the nose go down. If I have 1 gear, 1 main down, 1 main up, I probably will do what you said, but then land flat, basically, with no gear.
Yeah.
So if you had your nose gear stuck, you wouldn't pull the emergency switch?
Oh, yeah, I would. I
Okay.
would. Yeah, in this case, it didn't work because there was something stuck actually in there, a bolt that became loose, and then it gets stuck inside the cowling.
Oof,
So
that's rough.
it just wouldn't come down. And that wasn't me. That was one of our instructor that did that. But did a beautiful job landing on the runway. And then as soon as it landed, the wheel became unstuck. And because the bolt was missing, the wheel just flew. And then was going down the runway. And the guys in their little car on the runway were just like chasing the gear and the wheel. And it was just rolling and rolling and rolling. And it went for like thousands of feet, just rolling down the center line. That was funny. Okay. All right. Tom, any more questions on that?
No, there's just both of the DPEs that I had for my commercial multi-engine add-on, as well as my multi-engine instructor rating. I would, when we were doing maneuvers, like one engine, or we had the gear up and it would start beeping, there is a button that allows you to silence that beeping, and I would reach up and hit that, and both of them told me don't do that.
No, don't do that.
Just let it beep.
Yep.
Because that will alert you that your gear isn't down.
Yep.
Because there's 2 types of pilots. Those are that have had a gear up, and those that are gonna have a gear up.
Well, 3 green, no red, confirm. That's my thing. And I for a long time, even when I flew single non-retractable aircraft, I would say it out loud. 3 green, no red, 3 green, no red, confirm. And to make sure, and if you're flying with somebody else, then they confirm. They look at the 3 green thing. No red means there is no red indicator that tells you, then you're good. And then, or you have one in the mirror. So on the Piper Seminole, for example,
Yep.
you had a mirror on the engine, on the left engine, that would look at the front gear because you couldn't see the front gear.
Mhm.
Most of the cases, you won't be able to see if the gear is down or not because it's a low wing aircraft, so you can't tell if it's down. So at least you get that indicator. 3 green, 1 in the mirror, no red, confirm. And that's what we had as a procedure. That works really well. So then you don't become one of those people that does that.
Right.
Okay. Let's talk about. You're going to say something.
Now we're good.
Let's talk about how we keep humans alive at high altitude. Okay.
How high?
Well, high enough that they could get in trouble. There's 2 different methods to keep humans alive at high altitude.
Oxygen and pressurization.
Oxygen and pressurization. There you go. So what does pressurization do? First off, why can't humans operate really well at high altitude?
Because a decrease in oxygen.
Is it?
To decrease in pressure.
Well, and subsequently oxygen that is
That is going to
into your blood
into your blood.
and
Okay.
thus to your brain.
So
And that condition is called?
Hypoxia.
There you go.
hypoxia. So, and that what you just said is something that a lot of people say, which is in theory, what's the percentage of oxygen at sea level in the atmosphere?
Like 14%, I
It's
think.
21%. Okay.
21?
What's the percentage of oxygen at 18,000 feet?
21.
21%.
Yeah,
Right.
it's the same
Yeah,
as
it's
you
the
go
same.
up.
It doesn't change. So the only thing that changes is the amount of, because of the pressure change, is the amount of air that you're able to get into your lungs. Your lungs, the way they operate, it's a differential pressure system, if in a sense, right? So you create a differential pressure. So as you get higher, you can't do that because every time you breathe, you can only bring so much air in there. 21% of that being oxygen, less air, less oxygen. So make sure that you explain it that way when the DPE asks you.
Okay.
So pressurizing. So obviously we pressurize, then we get back to a level that's appropriate. What's the altitude that we pressurize the aircraft at roughly?
I think it's 15,000.
15,000?
Well, what do
It
you mean?
depends.
I
It
was
depends
gonna
on
say
the
it depends.
aircraft.
There was
What do you mean we pressurize that? We
Oh,
start like the altitude that the airplane will be at
The
as it
cabin,
climbs?
the cabin
It's
pressure.
about 8,000 feet.
8,000
Oh,
feet. Yeah.
I didn't realize that's what you
Yeah.
meant.
Yeah, cabin pressure.
pressure.
Oh, starting pressurization, at what altitude
At-
do we start to pressurize?
At 15,000.
Yeah, I mean, it depends on the pilot. You can do whatever you want. In most cases, above 8,000.
Above
you
8.
can start to do it if you want to. Aircraft, I think we were talking about this a couple of days ago. Aircrafts have a limit as to how much they can pressurize. So an airliner has a PSI differential of about 8. So you can do 8 PSI of difference between the outside and the inside. And past that, you can't. So that's why some aircraft are limited as to what altitude they can fly with a pressurization, because they don't have a powerful enough system that they can fly at 40,000 feet and simulate 8,000 feet. That's your PSID. That's the difference between these two. So a smaller aircraft is only going to be able to get to 22,000 feet and simulate being at 8,000 feet. That's the PSID right there, like PSID of 4 or whatever it is. So, and then the other method, let's say we don't have pressurization. What if we wanted to fly at, 15,000 in the 172, if that's even possible? What did you get to in the 172?
We took it to 13, but
13.
it was feeling pretty good. It could have gone higher.
Wow, interesting. So let's say we wanted to get to 15,000 feet. What's the other method we can use?
Supplemental oxygen.
Supplemental oxygen. Okay. And is there any limitation as to what we can use? Can we just go to the store, buy a little can of oxygen and use that?
I don't remember this, honestly. I remember I remember the altitudes, but I don't.
Okay, what are the altitudes?
I think I remember the altitudes.
All right, what are the altitudes?
12.5 and 14,000.
For what?
12.5 for greater than 30 minutes, 14,000 for any amount of time. And then
So what happens
For
at
the
those
pilot.
altitudes for the crew, the
for
flight crew?
Yeah,
Yep.
yeah. For your flight crew, you have to have supplemental oxygen if you're going to be
Have to have or have to use?
have to use.
Okay, have to use.
Have and use.
And use, yeah.
I'm going to use it. Do you
And
have
then-
any? No.
And then what's the other rule? There's one more rule.
And then anything above 15 was everybody, I believe.
Close. About 15,000 passengers must be provided.
Provided.
Now, the other rules still apply. The 14, and this is something, I don't know if you've noticed that ever with students, but I've noticed that students always think it's 3 different altitudes. There's a rule for pilots. There's 2 different altitudes, 12,500, 14,000. And then on the other side, there's a rule for just
for
passengers.
passengers.
The 14,000 foot still applies.
Yes.
The 15,000 foot only starts there for and up. For passengers, they must be provided. They don't have to use it. They must be provided with it. They probably want to use it, but
Oh, they'll be feeling good. Maybe not.
yeah. And then there's a recommendation. The FAA makes a recommendation as to when you should use supplemental oxygen. You remember what that is?
I think it's above 10,000 during the day or 5,000 at night.
Yep. So here, if you were to do a night flight
Night
in
flight.
Prescott, in theory, you should be using that. Okay.
We didn't talk though about, you said what was required of that. I said I remember the altitudes, but I didn't remember what equipment requirements were in there. Or
We're talking about
is that what you
the
meant?
oxygen type.
Oxygen type?
Yeah. So can we use medical grade oxygen?
Oh, yeah. That's good. Yeah. Go back to that question.
I don't think so, because medical grade oxygen is like 100% oxygen.
Okay. So there's a grade of oxygen that's more I don't know what the word is. It's
Pure.
more pure than medical grade oxygen, and it's I think it's ABO, aviation breathing oxygen.
It's aviation oxygen. So it's green tanks. But I'll tell you one thing that I learned over the years, and this might be controversial, but doing some research on that, it turns out all the oxygen is actually the same purity level. The only oxygen that's different is one that you use for building stuff for welding.
Like the acetylene torch.
And that's actually a higher level, I think, of purity. But medical oxygen and aviation oxygen, I think, are the same level. The only difference between the two is liability. Is like everything in aviation, right? You spark plugs in your car. Could you put them in an engine on an airplane? More than likely, but you can't because they're not FAA approved. So now you have to get the more expensive cat because of liability. You pay more because these have been approved, reviewed by the FAA, all that good
So
stuff.
it's essentially FAA approved oxygen.
So it's essentially what it is. It's a different process to go through it. And the reason, though, that all of this is also the amount of moisture that is in the bottle. So that's why you don't want to use any kind of stuff, because your aircraft, if you have an oxygen system, you have two different types. You can have portable oxygen system, which is just a tank that you can take with you, like, grandma at Walmart that has it and puts it on. Or you can have the already installed system in your aircraft, in which case you would get that service. Somebody would come in, put oxygen bottles in here, turn it on, and then now you have a whole system that provides oxygen to everybody on board. And these are typically a bit more exposed because they're maybe in the undercarriage of the aircraft, so they could be in much colder temperatures. So you don't want that oxygen with humidity in it, because now you can freeze lines and it can become a bit of an issue. And then also, what's one of the things that when you handle oxygen bottles, what is the one thing that you have to be very careful with? Do you know?
I probably should, because I've done welding and stuff before using oxyacetylene, but
Greasy hands. Any kind of grease. Why? What happens when you have oxygen?
fires.
Yes.
Yeah.
If you have any source of a fire that gets near any of this oxygen plus oil, then it's gonna blow up. It's gonna react. So you need to be very careful with that. They even say, like, things that you put on your face. If you're an airline pilot and you use a mask and you put that on, stuff on your face that could actually react, and if there is a source of ignition anywhere, then you can get in pretty big trouble. So anything with a hydrocarbon, I think it's called hydrocarbon. Okay. What else do we have in here? De-icing and tie-icing, not a whole lot to say at the private pilot level. ELT, what's the ELT?
Emergency location transmitter.
Yeah, locator transmitter. What does it do?
It activates and, God forbid you crash, tells people where you crashed.
That's right. Yep. So it's a locator. How's it actuated?
It can be actuated manually or via impact.
Yep. What else is there to say about the ELT?
When can it be tested?
Oh, yeah.
It's the first 5 minutes after the hour.
Yep. First 5 minutes of the hour. And then there's a battery in there. How often must the ELT be inspected?
Inspected.
Yep. The entire unit.
Is it every 12 months?
Yep. Good guess. And then the battery must be replaced.
Every 12 months, or when half the useful life of the battery has...
Close. Half the useful life is correct. Not every 12 months. It must be replaced.
Or 1 hour of continuous use.
1 hour.
1 hour of continuous use.
So I thought the 12 months was...
That's the inspection.
Well,
so,
and I combine the inspection and the battery replacement.
Yep. Okay. I think this is it. We're getting close to our time here, and we've pretty much done with this chapter. So we'll move on to the next one next time. Thanks for joining, and keep studying. See you guys next time.